Hello, loves. Get ready today for some applications of systems of equations. Make sure when you're writing these notes you're putting those titles down at the tops of your papers. I notice some of you are skipping out on that simple little step. Also make sure you get the EQ written down in the first couple of lines. I notice you're skipping out on that a little bit too. So take a moment also, and before we get going, write down these couple of little reminders I have for you right there. Pause it and then come right back. Okay, you're back, right? Did you actually write it down? I want to see it on your notes tomorrow. Hey, so today we're just looking at writing a system of equations so that we can actually use it in the real world. That's all we got going here. You've been doing this for 3 weeks already. We're just going to focus in on it intensely today in class. So with those reminders, use those to help you get through while you're writing your equations. If you have to make sure you get the right variable and the right number together, well, that makes sense, right? You wouldn't put 24 with apples because they don't go together. 24 goes with oranges, so make sure you write them accordingly. Also, remember that you write what you read. 98% of the time, it's literal translation. So if it says 24 oranges, and oranges are x, then I'm going to write 24x. Then it says and is just the mathematical symbol plus. And then we've got 15 apples over here. 15y, because they tell me down here that apples are y. Is the mathematical symbol for equals, and then they give me a total right there. End of sentence? Probably the end of my equation. So now I'll do the second one. Right here we've got 15 oranges. Don't let the word throw you, it's just a number, right? So 15 oranges, and is the plus, 12 apples. This time they didn't say is, they said cost, but that's your key word to use the equal sign again. It's a total, right? 867. Now I've got myself a system of equations. I can actually use this to solve and figure out the cost of each orange and each apple. Alright then, so if we're going to solve this thing, we've got to think what's the best way to solve this system. Do you think graphing would be a good idea? I'm going to have to go with no, because I've got decimals in the problem. Next we could talk about substitution. That was the second method I taught you. Substitution would be pretty dreadful because it would take a lot of work to solve for x or y in this case. Well, so, looks like elimination might be a really good plan because, look, my x's are already stacked up and my y's are already stacked up. Now I just got to make it work so that I can get an answer. I can't think of anything off the top of my head that's 24 and 15 both go into evenly. But when I look at 15 and 12, I think of the number 60, and I could make both those numbers 60 really easily. So I think about it, what number times 15 gives me 60? Happens to be 4. Down here, what number times 12 gives me 60? That number is 5. They're both positive numbers in the problem, and I've got to make one of them negative. It don't really matter which one, so I'm just going to choose that one right there. Now we're going to distribute those numbers in and rewrite our equations. I'm going to pause to do that so you don't have to sit and watch me do all the calculations. I'll be right back. Alright, I'm back. So it looks like that first equation is now going to become, I don't know what it's going to become, hold on. Oh, there it is, 96x, there's my 60y, and I get 4944 on the end. Now I'll do the blue equation. Alrighty, so when I multiplied that -5 through the blue equation, I got this new blue equation down here. Now everything's all nice and set up, so I can just get rid of those 60y's just like that. Now when I add my equations straight down, I end up with 21x equals $6.09. Be aware, sometimes when you're doing this elimination, that dollar amount might turn out negative. Usually it's going to work out in the end if you've done everything else right though, so don't panic. Now that I've got that little bit of information, I can finish this out by dividing that 21 off. 6.09 divided by 21 tells me that x equals 29 cents. That means that oranges are 29 cents a piece. Now I've got that information, I've got to go find out how much the apples are because it asked me about that too. I can plug it into any of those equations I see up there. So I'm going to probably pick the blue one because it's got a slightly smaller numbers in it. Alright, so I'll plug the 29 in for x, and now I get to do a little bit of math, and I'll get 435. Now I can move that 435 over and start solving for y. I think it's 432. You might want to check my math. If I divide that 12 off, it looks like I get 36 cents. That means that apples are 36 cents a piece. Now make sure you've answered the question. By the time you get to the end of some of these long buggers, they really kind of lose track of what it is they wanted from you. So I'll come back up here, find the cost of each apple and orange. And I know I just totally did not read that straight, but it looks like that's what I've done. 29 cents per every orange, and then 36 cents for every apple. There you go. That's all you got to do. Moving on down next, we got ourselves some more perimeter, because I know you guys love those perimeter problems so very much. Again, oops, I just want you to write what you read. It says the perimeter is, and it says perimeter of a rectangle, so it makes it very easy. You know that's 2 L's plus 2 W's. Is the equal sign, and then they tell us the perimeter is 32. Second sentence means our second equation usually. It says length is. So this time I'm going to write L equals. Then it goes on to tell me 1 centimeter more. That means 1 plus. 1 more than twice the width. Well, that means multiply, so I get 2W. Now I'm ready to solve it again. It wants the dimensions. That means find out what L and W are. Remember to be really, really careful when you got those L's in there. Don't get them all mixed up with your ones. It makes for really, really messy algebra. So here we go. In this case, I'm going to think, alright, graphing, is that a good option? Nope, probably not. That's almost never really a good option, to be honest, unless that's what the problem wants from you. Substitution? Bingo. I know you don't love this one so much, but it really makes a lot more sense than trying to use elimination on this one. L is already all by itself, so let's just plug the bugger in. Here we go. If L is equal to this stuff right here, I'm going to take that stuff and plug it in right there for the L. Now you remember the drill here. We're all the way down to just one variable, the W. So now I can just use a little distributive property and a little bit of stuff we learned a long time ago back in September, and I'll know what that W is. Alright, so check it out. Right here, I did the distributive property, and now I don't have any parentheses left. Next step, I actually combined my like terms. That 4W and the 2W gave me the 6W right there in the middle. Now, I can just use a little bit of quick math. Move that 2 over, divide by the 6, and I'll know exactly what my width is. 6W equals 30, then W must equal 5. Now that I've got my width, I'm going to take it back up here and plug it in to get my length. Right up there. Because the length is just 1 more than twice the width, so that makes it easy. Length is 1 more than twice the width, which I now know is 5. So my length is going to be 11. That's the dimensions of my rectangle. Remember, you can always plug these numbers back in and check your work. Here we go, the third grade class going to the zoo. They spent money on tickets, and they tell us how much each ticket's cost. This is where you got to go back to that reminder, where lollipops plus lollipops does not give you teddy bears. It gives you more lollipops, so make sure you're paying attention to what you're putting together. In this case, right here, they spent this amount right there. That's money. That means that I've got to add money together to get a total of 750. Down here, it says they bought 175 tickets. Total. That means I better be adding tickets together to get 175 total. So here we go. It says right there, $6 for adult tickets, That's 6A. Remember, that's a dollar amount when you get done because the 6 represents money and the A represents the number of adult tickets. And is your plus $2 for student tickets, 2S. So if I'm adding money plus money, I better get money in the end. Well, remember, there was our money amount right there. My second equation probably has something to do with those, with those tickets right there. If I'm going to get a total of 175 tickets, then I probably ought to add adult tickets to the student tickets. There's no other numbers here because the other numbers mean money, and money plus money does not give you tickets. So what do you think this one's set up for? Substitution or elimination? I bet you just said elimination. That's what I would go with. Remember, you can eliminate whichever variable you want. I'm going to go for the 2 S's right here because 2 is a smaller number than 6, but it really doesn't matter what you choose. I'm going to have to multiply this one all by a negative 2 in order to cancel out the positive 2 S that I've got on top. So, oh dear, what's that? My brain's a little tired, so I'm going to use my calculator, even though I know I probably should know that in my head. You know what's sad though, while you're waiting for me to calculate this, is that I'm kind of old and I can't see this calculator in the dark. So I don't know what I'm calculating. It's a negative 350. Now we'll bring that original other equation down, stack it up. And now I'm ready to eliminate because my S's are going to go away. If that's the case, adult tickets, the number of adult tickets that was sold, is 100. Now remember, once you got that, you can go back and plug it in wherever it's easiest to figure out the rest. So there you go. I just went back and plugged it into the simple equation right there. And when I did the math and moved that 100 over, I found that there were 75 student tickets. Less problem. This one's a tricky one. I want you to really watch these money problems. The tricky piece is right there and right there. When they tell you nickels and dimes, your brain thinks 5 and 10. But it's really not true. Remember that a nickel is 0.05 and that a dime is 0.10. If you use any other kind of reform of the number 5 and 10, you end up with a crazy bad answer and you miss it on the STAR test. So please watch out and be careful. Here it says he's got a jar of 247 nickels and dimes. That's actually your first equation right there. Not ready to deal with the 0.05 and the 0.10 yet. If I have nickels, I'd call those N, and dimes would call those D. Don't you agree that coins plus coins equals coins? So nickels plus dimes is 246 coins altogether, so that makes sense. Kind of that lollipop concept I've been trying to teach to you guys, right? Now is where we got to use this value and that value to get a total of that value right there, because money plus money always equals money. So 0.05 for every nickel and 0.10 for every dime would give us a total of 1995. This is the tricky hard one right there. Be careful with that. Go back and listen to it again if it wasn't making any sense the first time. Money plus money equals money. Again, I got it all nice and stacked up here, so I think I could probably use elimination pretty easily to solve this one out. Let's see. I think maybe we'll just try to get rid of the nickels. It doesn't really matter what I choose here. So to get that top n to be a negative 0.05 n, I'm going to have to multiply times negative 0.05. Remember, make sure that you distribute that to every piece. You've got to change that equation equally to make it legal. Alright, so after I distributed that green 0.05 through, I get the red equation right there. Then I brought down... Oh wait, am I lying? Yes, I'm totally lying. Sorry. After I distributed the 0.05 green stuff, I got this purple stuff right there. I didn't have to bring anything down because I just stacked it right under the other original red equation. Now I'm ready to eliminate, because those go away. This leaves me with 0.05D equals 765. Divide that 0.05 off, and your number of dimes is going to be 153. Now that I know the number of dimes, let's go back and plug it in, figure out how many nickels I'm going to have. Wow, that was kind of messy. I'm pointing to that purple equation inside. N plus 153 is 246. To solve for n, I just got to move that 153 over. It looks like I'll be left with 93 nickels. And that is that. Don't forget to go back and write your questions and write me a good summary, and I'll see you later. Oh, you know what? I can't say it. I can't sign off just yet, because guess what? It was told to me today that Miss Carly and Mr. Jesus had birthdays in the last couple of days, and we totally missed them. So, birthday shout out. Happy snappy birthday, mates. Oh, that was Australian, wasn't it? Maybe they say that in England. I don't know. But happy snappy birthday to both of you. I hope you had a wonderful birthday, and I'll see you tomorrow.